Hi everyone, thanks for liking, commenting, sharing and watching these videos. Now in this video we'll learn about adiabatic process, important topic under thermodynamics. Okay, and this many questions have been asked from this topic. I have already shared one video with you which was entropy change in adiabatic process. You please watch that video, that will be very helpful for you. And this video will talk about basic adiabatic processes, what all are happening, right? So we'll start with the first one. There are three possibilities. So first one is reversible adiabatic, other could be irreversible adiabatic. Then there can be free expansion cases also under adiabatic. So what is the basic difference in all three cases? Let's understand this first. So reversible, irreversible and free expansion. If we talk about reversible adiabatic, so your approach will be slightly different. You will say, you will use the first law of thermodynamics and that too in differential form, because as we know, the processes which are reversible, they can always be expressed in terms of differential terms. So we can write du is equal to dq plus dw. Now remember, we are using chemistry notations. If it is physics notation, you can say dq is du plus dw. But in chemistry, we use it like this. So we know that du is dq plus dw. That's the first kind we will write. Okay, now since it is a reversible process, then we can say, as per the definition of adiabatic, dq is to be 0. Since adiabatic, we can write dq is 0 and hence it will become du is equal to dw. So this will be the opening sentence. If it is irreversible, you will say delta u is q plus w. See, I'm avoiding this time any small d word. And then we will say q is 0 since it is adiabatic process, and adiabatic process does not allow any heat exchange with the surrounding. So q is 0, hence delta u will be w. So see, I'm writing things, but there is a small difference in these two things. And the last one, when it is free expansion, we will say delta u is q plus w. Q is 0 since adiabatic, okay, as we have done earlier. At the same moment, we will say w is also 0 since it is free expansion. What is meaning of free expansion? W is equal to minus P external change in volume, but if your outside pressure is 0, that's called free expansion, so work done will be nil. Hence, if you put all these two equations, you get delta u is also 0. So this is again a special case where all three things are 0. Okay, and I have discussed in earlier videos, but you can't say entropy of system is 0 for this. So please refer that video. So I hope you understood this. Now come to the treatment of this part. Du can be written as n Cv dt if it is n moles, and if it is just 1 mole, you can say Cv dt. And what is dw? dw is written as minus P external dV. Okay, and as we know, in reversible case, P external will match with the pressure of gas at each and every moment. So I can say P gas dV. If it is ideal gas, can we say, if it is ideal gas, P is equal to what? nRT by V. And we can use this result. So Cv dt is equal to minus nRT dV by V. I hope you're getting this also. Now the next job in front of us is that we will take this detail and try to arrange it in some proper format. So let's do this. Yeah, let me draw this thing. So you can say, find this we have right now, and this was n Cv dt. So we can say one option is n and get cancelled, and we have something like Cv dt upon t is minus r dv upon v. Okay, so you can do the integration of this both side, putting the limits t1 t2, putting the limits v1 v2, and we can get Cv ln t2 over t1 is equal to minus r ln v2 over v1. And then we will write it as T2 upon T1 raised to power Cv is V2 upon V1 raised to power minus R. And what is Cv? As per our information, what is Cv? So we know Cv is R upon gamma minus 1. So I can write it as T2 upon T1 raised to power R upon gamma minus 1. We can cancel out R both the sides, okay, or we can put 1 by R both the sides and then R get cancelled out, that we can think of. So T2 upon T1 raised to power 1 upon gamma minus 1 would be equal to V2 upon V1 raised to power minus 1. Now, which is equivalent to V1 upon V2? Now just cross multiply these terms. So we can say T2 upon T1, 1 upon gamma minus 1 can also be written as T1 upon T2, okay, gamma minus 1. So if you understood this whole thing, we can just rearrange the whole structure and finally we can get the results accordingly. So let's do that. Finally, we should get TV power gamma minus 1 is a constant, right? This term should come as a constant here. That part we can do. So I hope you understood the whole discussion. and we can understand every other thing which is required for this discussion. All right, so this is the formula that we get for this case. Similarly, we can derive some other results like PV power gamma is constant and other results by just modifying this result. Now come back to this part. In this scenario, when it is irreversible, delta U is W, hence NCV T2 minus T1 or T final minus T initial will be equal to minus P external V2 minus V1, and this is the treatment of this. Okay, and then using this we can always solve for temperature if other things are given. So I hope you understood the whole video where we talked about reversible, irreversible and free expansion processes. Thank you very much for liking, commenting, sharing, and please do subscribe also these videos so you can get many more videos. Okay, thank you.